Hey everybody, so we are going to be talking about the law of sines and cosines. So pretty much you're going to be able to solve for side lengths or missing angle measures, even if a triangle is not right, using the law of sines and cosines. Now you use this law more so in pre-cal, but you're definitely, if you get exposed to it in geometry, it won't hurt you. I am going to be color coding on the inside, so make sure you follow along. I just want to remind you that for a right triangle, if you are given both of the legs, your opposite and your adjacent, by the way, that means you're using the tangent ratio. If you have a hypotenuse leg that's been given to you, you're either going to end up using the sine or the cosine ratio based upon the degree that you have, or just, based upon what you've been given. If you have an acute angle with the hypotenuse, same thing, you're going to be using the sine or cosine. And then if you've got an acute angle in the leg, you can pretty much use kind of any one of them and try to figure it out from there. You just have to set it up and draw a picture if it makes sense. Now, if you have any triangle, here's what you need. All right, so if I've been given angle, angle, side, I've got an angle, and a non-included side, then I'm going to use the law of sines. The same thing happens if I've got an included side, because it doesn't matter. All I need to apply the law of sines, I need two angles. And for the law of cosines, you'll notice that both of them have at least two sides. All right, so let's talk about the law of sines first. And I am going to actually be highlighting, like I said, I'm going to be color coding with angle A and its opposite, side length A, angle B and its opposite, side length B, and finally the same thing happens with angle C and its opposite, side length C. You'll notice that the lowercase means it's a side length or a line like we've been talking about, and of course with our angles we do go ahead and capitalize them. So we've practiced using trig, how to do this for right triangles. Well, what ends up happening is that the law of sines shows the proportional relationship between angles and their opposite sides. And it can be used to find side length and angle measurements for any triangle. So the way that I have this written out is that the sine of angle A over A is going to equal the sine of B over lowercase b, which is angle B, or sorry, side length B. And then you've got sine of C over side length C. Notice it's corresponding with that angle. So whatever is opposite that angle is the side length right under it. A, B, C, you go in order. And it's just an extreme proportion. It's an extended ratio. So here's the example that we have. We have angle RST. So I like to color code it just so I remember what I'm working with, which ones are my opposites and which ones are those side lengths. And sometimes you're not going to be given everything to finish out your extreme proportion, and that's okay. And if you want to label it, you can as T. That is okay as well. And now I want you to notice that when we're highlighting these angles, what we're really talking about is the angle measure here. So this blue is right there, and then red right there. Now, we can go ahead and figure out what this third one is because we know that a triangle adds up to be 180. So if I subtract 125 minus that 180 and also subtract 24, then I end up getting 31 degrees. And that's what angle R is. Now, we can go ahead and set up our ratio and our proportions. So I've got sine of R over lowercase r. Then I've got S. And then I've got T. Now, I always like to write this out, so then I can just drop the numbers in. It helps my brain and yours process it better when we have places to put things in. So now I'm just going to drop these numbers in. We're going to have sine of 31 over 6.8. We've got sine of 125 over x. And then sine of 24 over, I don't know, t. We don't know. We haven't been given. So in this situation, and I forgot to write this in, all we're doing is we're going to find x. So of these three ratios, we don't need the entire proportion. We only need two of them. The one we don't need is this green one, the one with angle T. We're not solving for it, it doesn't apply to us. So you can just cross multiply and use this one. So when I cross multiply, I get x times sine of 31 is equal to 6.8 times sine of 125. Divide both sides by sine of 31. Sorry, guys. So you're dividing both sides by sine of 31. On the left side, it ones out, so we're fine. And then the only thing that you're going to need to put into your calculator is this right here. Now remember, when you're putting these things into your calculator, you must make sure you're in degrees mode. If you're using this type of a calculator instead of your TI-84, then you're going to need to use parentheses. So I'm going to put my numerator in parentheses and do 6.8 times parentheses sine of 125. I'm closing my parentheses and then dividing it all by sine of 31. And now I'm going to go ahead and calculate that, and that gets me around 10.8. And we'll just have you round to the nearest tenth here. So you should get that x is approximately 10.8. And so even though it wasn't a right triangle, you were able to figure out that side length. All right, so now let's do the law of cosines. I'm going to do the exact same thing that I did here. And I'm going to highlight the angle with the opposite side, whatever matches with it. All right. So just like the law of sines, the law of cosines can be used to find side lengths and angle measures of any triangle. So given triangle ABC, here are the formulas that you can use. And I'm going to give it to you for every single angle and side length. And I am color coding this just to help you guys out. If you do not want to color code it, you don't have to, but I do highly recommend it as it will help you guys out. So here are your three formulas. Right? So I want you to notice that the letter by itself is for the side across from the angle that you're going to be taking the cosine of. So look right here. You've got a squared here, and then you're taking the cosine of it. B, cosine of angle B. Side length C, and you're using angle C to find and using that cosine for it. So look right here. So the letter by itself is the one you're taking the cosine of. Now notice that you do not have the side opposite the only angle you know, and that these letters right here are the same as these. And if you want to use arrows instead, you can do that as well. All right, so we're going to do an example with this. And again, I recommend that we go ahead and color code it, especially for the law of cosines, because it does kind of, you're like, this is a lot to take in. And you have to figure out which one it is that you're looking for. Remember, I want you to solve for x. So let's highlight angle J and its opposite side length J right here. And I'm so sorry, the babies are so obnoxious today. Here's angle K right here and its opposite side length K. And then we've got side length M opposite angle M. You'll notice that our x is with angle J. That means we're going to end up needing to take the cosine of this. All right, and that's the side length that we're going to use first. So this is going to be 1.9 squared is going to equal blah-de-blah-de-blah times the cosine of angle J. Or if you want to put x there instead, since we're solving for x, you can do that as well. And then the other ones are your b values, which is your side length of k. So we've got 1.3 squared. This is times 1.3, and I'm putting in my final value, my green value, or c, and that's 2.1 that I'm dropping in to its spots. And this is not a superscript or a subscript. I just ran out of space and didn't plan accordingly. All right, so now what we're going to do is I recommend that we expand anything out that we can. So 1.9 squared gets me 3.61. 1.3 squared plus 2.1 squared gets you 6.1. And then negative 2 times 1.3 times 2.1 gets me 5.46. And that still times my cosine of x. And that's the one that, remember, we are looking for. So first things first, we are going to go ahead and simplify we're going to solve, and we're going to go ahead and do our inverse, and we're going to subtract that 6.1 from both sides. And we are left with negative 2.49 is equal to negative 5.46 times cosine of x. All right, so in order to get cosine of x all by itself, we're going to have to divide both sides by negative 5.46. This one's out, and I get that the cosine of x is 2.49 over 5.46. Now, the only thing that I was able to simplify out of this just by first glance is that 2.49 and 5.46 were both negative, and a negative times a negative is a positive. Or a negative divided by a negative is a positive. Doesn't matter either way. So because we don't know what the angle measure is, remember we're going to have to do the inverse trig function. We're going to do cosine inverse, and we're going to put our ratio in. And that's going to give us our angle measure that it's equal to. So let's type this into our calculator. We're going to do inverse. Notice how they all pop up. I'm still in degrees mode. Cosine. And again, it's typing it as arc cosine, but that's okay because we know that just means inverse. We're putting in our ratio, 2.49 divided by 5.46. And we get about 62.9. And because I didn't tell you where to round to, I'm just going to tell you right now. Go ahead and round to the nearest tenth. And so that gets me approximately 62.9. Now, do remember that this is actually an angle measurement. I would typically say, hey, put the degree sign in there. But you don't need to because your x value already had it to begin with. So we're only solving for x, not the angle measure, so to speak. All right, thanks for watching.